we could be the only advanced civilization in the observable universe. Imagine Earth as the sole cradle of intelligence in this vast cosmic arena. Astronomers worldwide are captivated by the latest groundbreaking findings from the James Webb Space Telescope, JWST. It has managed to capture the faint, elusive glow of what appear to be city lights, 7 trillion miles away from Earth. This monumental discovery isn't just a milestone. It reshapes our perception of the cosmos. Scientists are now meticulously analyzing this data, searching for clues that could unlock the mysteries behind these distant, puzzling lights. The implications are staggering, potentially indicating that we are not alone in the universe and that life thrives in ways we cannot yet comprehend. Could these far-off illuminations be signs of alien civilizations? What does this mean for our understanding of life beyond Earth? Join us as we delve into the awe-inspiring findings from JWST, which recently detected what seems to be city lights at a staggering distance. Launched on Christmas Day 2021, the JWST was designed to surpass the Hubble Space Telescope in capturing extraordinarily sharp images of celestial bodies, planetary systems, and more. One of its key scientific missions is to study the formation of the earliest galaxies by observing the distant regions of the universe. This is possible because the light we observe has traveled billions of years, allowing us to see these objects as they were in the ancient past. Distances in space are measured in light years. The distance light can travel in 1 year, and JWST's observations have taken us back billions of years. One of JWST's first iconic images was presented on July 11, 2022, by President Joseph Biden at the White House. This was a deep-field image focused on the SMACS 0723 galaxy cluster, located 4.6 billion light-years away, with even more distant galaxies visible behind it. These background galaxies were magnified by the cluster's powerful gravitational field, which acts like a cosmic magnifying glass. In one case, astronomers discovered that light from a distant galaxy had taken 13.1 billion years to reach us. As light travels through an expanding universe, it stretches, shifting from visible wavelengths into the infrared. This shift allows JWST to capture infrared images of galaxies that Hubble could only partially see, unveiling how galaxies have evolved over billions of years. Perhaps most astonishingly, JWST captured these deep-field images within hours, whereas similar images from Hubble took days. Every time it looks into the sky, JWST seems to uncover countless galaxies, each holding clues to our cosmic origins. But galaxies aren't the only objects that magnify and bend light. Researchers recently used JWST to study a pair of galaxies known as VV1191, to examine how light from one galaxy altered as it passed through the other. This research will reveal characteristics of the intervening cosmic dust and gas. One particularly exciting discovery involved possible auroras on a brown dwarf star, a star-like object too cold to sustain nuclear fusion. The JWST team observed auroras on this distant brown dwarf, which is releasing methane, a phenomenon even more puzzling since it lacks a nearby star to drive these auroras. Normally, auroras occur when energetic particles from a star like our Sun are funneled by a planet's magnetic field to its poles, where they interact with atmospheric gases, creating beautiful light displays such as the Northern Lights. Jupiter and Saturn also have auroras due to solar wind interactions. Yet, the brown dwarf WISE 1935 has no star nearby, making its auroras a fascinating mystery. Hopes for detecting extraterrestrial life continue to focus on nearby star systems like Proxima Centauri and TRAPPIST-1, just 4.4 light-years away within the Milky Way galaxy. With evidence of water on TRAPPIST-1's exoplanets, scientists are optimistic that signs of life could eventually be found. Last month, JWST identified an exceptionally massive black hole, estimated to be 40 million times larger than our Sun. It is shrouded in a thick cloud of dust, which causes it to emit a reddish glow as it devours everything in its vicinity. This black hole, located 129 billion light-years away, isn't a threat to us, but its rapid growth and massiveness are astounding, offering new insights into the evolution of black holes and their host galaxies. The discovery of similar supermassive black holes in the early universe has ignited debates about whether these black holes formed from stellar remnants or directly from the collapse of primordial cosmic matter. By analyzing JWST's images, scientists are gaining unprecedented insights into the formation and behavior of these ancient cosmic giants, which remain shrouded in mystery. Through JWST's lenses, we are discovering strange phenomena almost daily. As the telescope continues to send images back to Earth, we're given the privilege of peering into the cosmos, witnessing the captivating lights of planets and stars scattered across the universe, countless light-years from home. The James Webb Space Telescope has enabled us to observe far beyond what our eyes can perceive. For example, a peculiar sight resembling a question mark has recently been detected in deep space. For over 20 months, Webb has been navigating through space, sending back images of its findings with its advanced near-infrared camera. One such image released by the European Space Agency shows two young stars in formation approximately 1,470 light-years away from Earth. Notably, at the bottom of the image, there's an unusual orange mark that resembles a flipped question mark. Despite appearing small, this feature is massive. Captured while observing the young stars, named Herbig-Haro 4647s, the stars are surrounded by vast disks of dust and gas and are only a few thousand years old. The question mark shape may appear as such due to Webb's unique perspective. Without further research, we may never be able to identify it with certainty, but experts believe it could be a distant galaxy or galaxies interacting with one another, causing the distorted question mark shape. In addition to these unique findings, Webb has opened new avenues for exploring other planetary systems, such as TRAPPIST-1, a star system located 40 light-years from Earth with 7 rocky exoplanets. This discovery could help scientists answer the Fermi paradox, the mystery of why we haven't found advanced extraterrestrial life, despite its probable existence. NASA's search for habitable planets involves examining not only a planet's size and distance from its star but also atmospheric compositions. 6 years ago, the infrared Spitzer Space Telescope identified the 7 rocky TRAPPIST-1 exoplanets orbiting a single star. Now, Webb has measured the temperature of TRAPPIST-1b, one of these planets, and detected its faint mid-infrared light. This marks the first time light has been observed from an exoplanet this small and cool, similar to the rocky planets in our solar system. The discovery of the TRAPPIST-1 planets thrilled astronomers because these planets are Earth-sized and located within the habitable zone, where liquid water might exist. This makes TRAPPIST-1 an ideal laboratory for studying rocky planet atmospheres. Although at 235 trillion miles from Earth, these planets are well beyond our reach. TRAPPIST-1 orbits a smaller, redder star, an M-dwarf, which is more common than Sun-like stars and often has rocky planets in orbit. Despite their frequency, these M-dwarfs are more volatile than our Sun, often emitting high-energy flares that could impact a planet's habitability. Prior observations of TRAPPIST-1b were insufficient to determine whether it had an atmosphere, but Webb's measurements showed a much higher temperature than expected for a planet with an atmosphere, ruling out that possibility and removing it from the list of potentially habitable worlds. Webb's capability to observe and analyze atmospheres and temperatures of distant worlds like TRAPPIST-1b is groundbreaking. It also allows astronomers to study weather and climate on exoplanets, contributing to the quest for life. Recently, Webb observed the weather of a giant planet called WASP-43b, located 280 light-years away, which is similar in size to Jupiter but much closer to its star. Known as a hot Jupiter, WASP-43b experiences temperatures of around 2,200 degrees Fahrenheit on its day side, while the night side, permanently shadowed, is cooler at about 1,125 degrees Fahrenheit. The rapid movement of heated air due to supersonic winds, over 5,000 miles per hour, prevents the formation of methane, which is otherwise stable. Webb's sensitivity and stability enabled scientists to map the temperature across WASP-43b's surface over a 24-hour orbit, offering insights into the extreme weather patterns and atmospheric conditions on distant worlds. The James Webb Space Telescope has become a revolutionary tool for space exploration, providing previously unimaginable insights into the nature of distant planets, their atmospheres, and even their weather. This is only the beginning of Webb's cosmic journey, which is expected to continue unlocking the mysteries of the universe.